This is AQA GCSE Chemistry. It's a dual award and therefore triple award topic as well. And we're looking at bonding. This is video number 1. In this video, we are going to look at melting points and some of the key information about the structure at different states of matter. As always, I'm going to recommend that you have a go at each activity as we go through and then pause and review. So, to begin with, let's have a look at this, taking us way back, potentially to key stage 3. In terms of volume, we know that a solid and a liquid have a fixed volume. They can't be compressed. But a gas has a variable one. We know that we can condense a gas, we can squash a gas. If you've ever squidged a balloon, you'll know that you can push those gas particles closer together. If we then think about the shape, a solid definitely has a fixed shape, but again, we know that a liquid will slosh about, the particles slipping and sliding over each other, so they're variable, and gases are absolutely variable. In terms of the structures, drawing a diagram, I've said at least 8 particles here, but you might want to draw your solid as a very rigid lattice structure with the particles in a regular order. A liquid, I've actually drawn a beaker around this to see that there's a less ordered structure, although they are still very close together. Whereas a gas will spread out to fill the entirety of the container that it's in. Moving on to quite an important practical task that you will carry out as a result of the work on states of matter. And on this one, we are going to consider the cooling curve of stearic acid. Now, you've got a method here. I'm going to recommend you read through this because it will be useful for you to be able to remember some of the key ideas. And now you've read it, we're going to go to some questions. Now, even if you've not done the practical, you will be able to think about some of the theory that underpins this, because that's ultimately what could happen within your exam. So in terms of plotting a graph, I'm actually going to put a graph up for you. This is not representative specifically for the diagram that we would do, but it does represent the shape. It also says a smooth curve, which is what you would be looking for if you were sketching it. But let's have a think about the rest of these questions. So we need to show where the label where the substance was solid, that's A, and that's after it's been a liquid, it becomes a solid and it's cooling and freezing, essentially. Then where the substance was a liquid, well, that's actually labelled on this one, and then where freezing is taking place. And this is a really important bit. The freezing is taking place at the point that the line flattens off. We then have the question about the freezing point of stearic acid. Now, within an exam, this would be you reading directly off a graph you've been provided with or plotted. Stearic acid is around 69.3 degrees C. And then describe as fully as you can the shape of the graph you've plotted and why it has this shape. Well, if you think about it, as something cools down, it's cooling down because heat is being lost to the surroundings. So temperature of the surroundings might go up slightly, but the temperature of the material is going to drop. However, during condensation and during freezing, and in the reverse of this, where we're heating, the same is true when we melt and when we evaporate, we get this flattening of the graph. The temperature stops dropping in these cases, and this is why the energy is being released when new bonds form at that time. So as a gas becomes a liquid, the particles come closer together. As a liquid becomes a gas, particles closer together or more strongly attracted to one another, more rigidly attracted to one another. And when you form a chemical bond or a chemical force of attraction, energy is released. So for this period, you are counteracting that reduction. You're actually getting some extra heat energy released. That takes us to the end of this video. Thank you for listening and goodbye.